Hello everyone, my name is David and today I'm going to repeat this video. Let's get started. Imagine a stadium-sized asteroid is going to hit us in a week. At these moderate size, a fireball brighter than the sun tears through the atmosphere at 60 times the speed of sound and destructive the power of 40,000 Hiroshima bombs flatten surface, killing millions. This isn't science fiction. Mercury's asteroid only were spotted in the last moment in 2019, asteroid OK, a big as a 30-story building discovered in one day before it lays Earth closer than some of our asteroids. Last year, an even larger asteroid MK was spotted 13 days before it passed closer than the Moon. If they hit Earth, they would unleash the destructive power of 3,000 and 9,000 Hiroshima bombs. Stunningly, humanity doesn't really have a plan for this. Scientists have observed all kinds of tricks to push dangerous asteroids away, painting so sunlight will deflect it, landing thrusters with steroids, scorching it with lasers, or even crashing spacecraft into it. But they all have a big problem. It's like an equivalent of trying to deflect a cargo ship throwing a bag of potatoes at it. They do move the asteroid with only a tiny bit. With these methods, you need to act years, even decades in advance to make an asteroid miss Earth. Very recently, scientists have developed a new spectacular way to destroy killer asteroids. With implement with today's technology, let's see how this works and 100 meters asteroid hit Earth, the secret weakness of asteroids. For a long time, people imagined asteroids as being gigantic stones made of rock and metal. But it turns out most of them aren't like that. They're most back closely gravel heaps of pebbles, precious mineral, and dust barely holding together, which means instead of some nudging the wind, do something better, pulverize them. The obvious choice is, of course, a nuke. So let's go. We load our nuclear warhead, launch it, aim at a deadly asteroid, and the asteroid destroyed the nuke. Asteroids approach Earth at 70,000 kilometers per hour, enough to cross Antarctica in 5 minutes. No bomb ever made could survive just an impact. So if we go head-on-head collision, the asteroid will wreck the nuke before it has a chance to explode. So, okay, easy. Let's explode the nuke before it touches the asteroid. Scientists has estimated a terminal distance, which is 100 kilometers. Asteroid being a few tens of meters above the surface. Launch, set the timer, and the explosion made a dramatic crater and nothing else. Unfortunately, in space, there is no air to carry a shockwave, and most of the explosion energy is lost. The rock will hit us in 2 weeks, only a few kilometers to the left, striking just a benefit with a nuke. It's like hitting a cargo ship with a washing machine instead of potatoes. Better, but still useless. So let's go movie routine. Add someone to asteroid, drill a hole, and bury a nuke inside to avoid all of these problems. This is impossible in theory, albeit suicidal in practice. Landing on any space body is a nightmare. Fairly on Big Mars, whose surface we know is almost perfectly, roughly 70% of our attempts has failed. So I imagine a chance landing a crew on a nuke on the asteroid. Even if we succeed, ruling the microgravity is painfully slow since there's no downward to pull you. So we need an agonizing amount of time that we don't have. Sadly, that's not the answer. You have to think less like Hollywood and more like Lumpjack. The smart way. If you want to spin a log, don't hit it with a rock. Use an axe, a dense and perfectly shaped tool designed to break things apart. In just the same way, scientists have found a new tool to destroy asteroids, super dense, ultra-fast cosmic bullets. We won't even have to shoot them. Our cosmic bullets are called penetrators. A few meters long, slim, and made up of tungsten, and metal way denser and harder than rock. They work in an extremely simple way. If we just put a penetrator in the way of the asteroid to float silently in space, from the specific of the asteroid, you wouldn't still see it's a few tiny bullets until you see them rushing you at 70,000 kilometers per hour. It doesn't matter who stands still and who moves. This is speed that goes far the longest time on the mission. We can't destroy too close to Earth because this fragment will slam into our atmosphere at one with the power of thousands of nuclear bombs. Our atmosphere is absorb isolated chunks. It make thousands strike together. The shockwaves will add up and kill millions. Instead, we get one day before impact when asteroids nearly hit 2 million kilometers away, 4 times further than the moon. That's a vast distance, but doable. Our current rocket can cover this about a week. We'll send us one penetrator about 2 meters long, weighing 2.5 tons. Once our rocket arrives, it puts the penetrator to cause maximum damage, and wait, a tiny ray of light appears in faster distance, and it's suddenly there, shooting us at the faster than speed of sound. We'll slow down time to see what exactly happens. Asteroid crashes into a penetrator so fast and so much violence that the power of 120 metric tons of TNT is released into the asteroid. The rock vaporizes and the tungsten melts away, carving a round tunnel across the asteroid. The damage is too much with all this energy looking a place to go. The asteroid splats into 1,000 pieces. The debris spreads into a diffuse cloud. A day later, the fragments hit Earth, disappear over hundreds of thousands of square kilometers, and turn to an apocalypse into a mostly harmless cosmic firework. So if we prepare and get everything ready, spotting a killer asteroid with 2 weeks is good enough, but just a small asteroid. If we hit a cosmic mountain, a planet killer carrying a destructive power of tens of thousands of nuclear arsenals, about non-avian dinosaurs will tell you, but they are dead. What if it's a planet killer? Planet killers are obviously so fast and powerful that they'll just end our life on Earth with one single strike. The most powerful ones are comets from the outer fringes from the solar system, so distant and dark, tracking them is impossible. Comets in a dirty ice ball are the size of mountain, more fragile of pure rock, but also traveling faster and violent, traveling about 140 kilometers per hour. In the 2020, the cosmic needle-wise, the power of 6,000 times all nuclear bombs on Earth was discovered just 4 months before its closest approach on Earth. Before what we see be 6 months before it's going to crash into Earth. Do we have a chance of surviving this? Unfortunately, it will be extremely hard for a bunch of reasons. First of all, planet killers comets are so hard, so more mass than a tiny killer asteroid. Simply breaking into millions of pieces would not be helping that much. The chance that hit Earth would be massive and numerous to get sky blaze and kill most life on Earth. So we need to make most, if not all, of its fragments completely miss Earth, but to do that much further away, as far away as Mars. To destroy a mountain, we need more penetrators, hundreds of thousands, and this is a huge problem. To travel, at least we need payload. We need 24,000 super heavy rockets, and today humanity has 2, and they're not finished yet. Even if industries in the world do nothing but switch to build rockets, they're still not finished in time. If they discover a planet killer today, there's literally nothing we can do about it. Except, what if we combine the penetrator with a bit of Hollywood and our old friend, the nuclear bomb? There's still a way. For this will work, we basically need to have all the parts ready beforehand. A rocket like NASA's SLS on a plan to take astronauts to the moon, so everything we need very much. As soon as the planet killer spot its way and wipe out this launch a single rocket in weeks, for 5 long months it's traveled to a continuous of space on Earth nevertheless continues. Finally, when it reaches its destination, bit beyond orbit of Mars, now we deploy 5 massive penetrators in sequence, one perfectly in 2 kilometers. The engineering challenge is attempting this horrible renaissance after 10, so very few astronauts will this one-way trip to the supervised process with no way home. They nervously watch fastest of all humanity watches the skies as screens. And then the moment comes. The icy mountain of death appears in full, and it's already here. Slow time down again. The first comet crashes into the first penetrator at 140 kilometers per hour, unleashing the power of 2,000 tons of TNT. Ice, rock, and tungsten liquefy in an instant. The energy thus impacts itself in dozens of meters deep in the mountain. Here's the second one perfectly hitting the same spot, punching directly into the crater, smashing, melting, and grilling. The third and fourth penetrators repeat the process again, and after smashing a tunnel about 100 meters deep. But this is a scratch on the surface of the monster. The comet is not really damaged yet. And final penetrators and its toxic load. The 300 megatron nuclear warheads to 20,000 times more energy than bomb destroyed Hiroshima and travel deep into the tunnel, and just before it hits the end, it explodes. This time the nuke works. Instead of hitting nothing in the vacuum of energy of the nuclear, smashes through a rock and gravitation, gravel, and ice until it vaporizes from the inside. There's so much shock and you punch that frozen world and billion years old dies within. Then a cloud of millions of fragments into spread all directions. Humanity is saved. To make this happen with reality, we make an planning and decision, and yet it's possible. Not a century with sci-fi technology, but the rocket's energy and knowledge we have today. So that's the end of the video. Thank you for listening. Goodbye.